Hello, everyone. It's Mr. Bowman. Last time you heard from me, we were talking about the idea of relations and functions. Now we're going to build upon that and we're going to talk about the composition of functions. So, what that really means is we're going to apply multiple functions. There's some notation for functions. So, for example, if you recall, if we said f of x, and let's say f of x is equal to x squared plus 1. Well, f of 2 would mean plug 2 in for x, square it, add 1, and you're going to get 5. Well, we're going to take that idea and we're going to, instead of plugging values in for x, we're going to plug other functions in for x. So, for example, if we're talking about the composition of f of g, the notation is slightly different. F open circle g of x really means f of g of x. So similar to what was done above when I plugged a 2 in, I'm going to plug g of x in place of x, apply the function f to that, and then we're done. Composition of g of f, well, that's g of f of x. And similarly, what we would do there is we would plug f of x in for x into the g function and apply function g. So it gets a little bit more complicated than that. So I want to do a few examples. So here are one example. F of x is equal to the square root of 2x, and g of x is equal to x minus 4. So f of g of x means find f of x minus 4, which really means let's take x minus 4 and plug it in place of x in the f function. So it's the square root of 2 times x minus 4. Which you could simplify if you want, but right now there's no need to do that. If we were to so-called reverse the process and take g of f of x, we would say, well, we're going to find g of the square root of 2x, and we would take the square root of 2x and plug that in place of x in the g function. So we would replace x with the square root of 2x, and then we would subtract 4. So why don't you pause the video and try number 2 on your own. Recall the notation. K open circle w of x means k of w of x, and w open circle k of x means w of k of x. So go ahead, pause the video, try these two, and see what you get. So what I would recommend is that anytime you get this notation like this, you rewrite it in this notation like this, because then you can think about it in terms of an order of operations. I need to first take the w of x function, plug that into x for the k function, and then simplify. So k of x squared, which means the square root of x squared plus 3. W of k of x, on the other hand, would be w of, we're going to take k of x, which is the square root of x plus 3, and plug it into the w function. So it is the square root of x plus 3, whole thing squared. I would recommend not simplifying this, and I will explain to you why in just a moment. All right, after finding the composition of two or more functions, we often want to find the domain of that composition. And there's an easy approach to doing that. Compose the two functions, don't simplify the results, and then find the domain of the unsimplified composition. And the reason is because if you have some restrictions on one of the functions to begin with, in other words, their domains do not contain all real numbers, then you're going to have similar restrictions on the composition. And if you simplify, you won't notice that. You tend to forget about it. So what we do to find domains of compositions is first, find the composition. Second, don't simplify it. Then third, find the domain of the unsimplified composition. So let's start with this example, f of g of x. So we're going to have f of the square root of x, which would be equal to the square root of x squared minus 1. Now, obviously, there are some restrictions on the domain of the square root of x. It's only numbers that are greater than or equal to 0. If you were to simplify this, very often people would write x minus 1. Okay? Well, if you did that, then you would lose the restrictions on the domain of the composition. We'll come back to that in a minute. G of f of x would be g of x squared minus 1, and that would be the square root of x squared minus 1, which, by the way, please don't simplify that to x minus 1. That's a common mistake. Find the domain of f of g of x. Well, we said that the function f of g of x is the square root of x squared, the square root of x, then we square it, then we subtract 1. Well, if you just think about that, what can you not take the square root of? Remember, we're talking strictly real numbers here. You cannot take the square root of a number that is less than 0. So the domain is any number from 0 to infinity. Now let's take a look at the composition g of f of x, the square root of x squared minus 1. Well, again, we've got a square root here, so we have some restrictions on our domain. So we know that x squared minus 1 has to be greater than or equal to 0. This gets a little tricky at this point because we have not talked about something called sign charts. So I think the easiest way to approach this is from a graphical point of view. So if you imagine graphing the function x squared minus 1, you basically have a function, a parabola that opens up with a vertex at the point 0, negative 1. And then you have to ask yourself, where is this graph at or above the x-axis? Well, if you put this into a factored form, x plus 1 times x minus 1 greater than or equal to 0, well, you know that the function is going to be 0 at x value of 1 and an x value of negative 1, and the function is greater than 0 anywhere where x is greater than 1 or anywhere where x is less than negative 1. So our domain for this function is the following. Our domain is from negative infinity to negative 1, including negative 1, because we can take the square root of 0 if we plug negative 1 in there, or from 1 to infinity. So what I'd like you to do now is I would like you to take the next two functions, find the composition, and find the domain. Pause the video, do that, and then come back and check your answers. All right, let's see how you did. So f of g of x is going to be f of the square root of x minus 16, which would be equal to the square root of x minus 16 whole thing squared. We'll come back to the domain in a minute. G of f of x would be g of x squared, which would be equal to the square root of x squared minus 16. So, again, the unsimplified version. very often people would simplify f of g of x and just say the square root and the squaring cancel each other out. Don't do that. Look at the unsimplified version and say to yourself, I know that x minus 16 needs to be greater than or equal to 0 because I'm taking the square root of x minus 16. So x has to be greater than or equal to 16. So our domain is from 16 to infinity. The next one, a little bit more complicated, but similar to the example we did together a minute ago. We know that x squared minus 16 has to be greater than or equal to 0 because we're taking the square root of it. If you were to factor that quadratic, you get x plus 4 times x minus 4, and you know that has to be greater than or equal to 0. But you can hopefully visualize that as a parabola that has a vertex at negative 0, negative 16, opens upward, and has zeros at positive 4 and negative 4. And you know that the function x squared minus 16 is positive for x values greater than 4 and is positive for x values less than negative 4. So our domain here is going to be any number that we can put in that when we square it and then subtract 16 is going to be greater than or equal to 0. So that will be from negative infinity to negative 4 inclusive, or from 4 to infinity. And that's it for composition of functions.